On geometric sequences. We are going to start by talking about what a geometric sequence is. Sequence is a sequence in which the ratio between any two terms is constant. And so the key word here in this definition is ratio. So what ratio are we talking about here? We're talking about a common ratio, something that's the same for between every term. So the common ratio definition is the numerical ratio. If you want to think of ratio, that's a fraction, sometimes whole number, right? 4/1 is still a fraction, between any two terms, and it has a special variable that is new this time around. It is the R for ratio. So what does that look like in sequences? Your first examples here are to determine if something is arithmetic, geometric, or neither. And if it is arithmetic or geometric, we're going to identify the common ratio or the common difference, and then write the next several terms. Okay? So 12, 24, and 48, we're going to decide, is it geometric or arithmetic? Now remember, arithmetic means they have a common difference. So I can take the second term, subtract the first term, and it should get me the same number if I do 24 minus 12. And the same number if I do 48 minus 24. So 12 minus 6, that's 6. 24 minus 48 minus 24 is 24. So this is not arithmetic. So let's check geometric. Now geometric has a common ratio. So we're going to divide 12 divided by 6, 24 divided by 12, 48 divided by 24, and see if we get the same thing. So 12 divided by 6 is 2, 24 divided by 12 is 2, and 48 divided by 24 is 2. So this is in fact geometric, and my common ratio is 2. Check arithmetic first. So we're going to do 8 minus 3.2, 20 minus 8, and we're going to see what that gives me. Now, 8 minus 3.2 is 4.8, and 20 minus 8 is 12. So there's no way that's arithmetic. So let's check geometric. We'll do 8 divided by 3.2, and we'll do 20 divided by 8. So 8 divided by 3.2, that would be a 2.5. 20 divided by 8 is 2.5, and just because they gave us one more, we're going to continue to check. We're going to do 50 divided by 20, just to make sure they're all the same thing, and they are. So number 2, again, is geometric, and my ratio is 2.5. We're going to check if this is arithmetic, geometric, or neither. So let's check it. 8 minus 4 is 4. 20 minus 8 is 12. So not arithmetic. Let's check geometric. So 8 divided by 4, that's 2. 20 divided by 8 is 2.5. We saw that over here. Those are also not equal. So this is neither. It is not arithmetic or geometric. We have to do 270 minus 810, and then 90 minus 270. Now remember, you're doing the second minus the first, or divided by, depending on what you're checking. It's not going to be biggest and smallest, so just be careful here. So 270 minus 810 gives me negative 540. 90 minus 270 gives me negative 180. Those are not equal, so we're not dealing with arithmetic here. Let's check geometric. 270 divided by 8's 10. 90 divided by 270. So we're just going to check that in our calculators real quick. You're going to get 0.333 repeating. It's all repeating there. So that is also the fraction 1/3 if you were to simplify that. 90 divided by 270 is also 0.333 repeating, or 1/3. And if you were to check that last one there that they gave you, 30 divided by 90, you would also get 1/3. So this is geometric. My ratio is 1/3. At least we've got number 5. We're going to start by doing 12 minus 20, then 4 minus 12, and we're going to check. This gives me a -8. This also gives me a -8. And if I do -4 minus 4, that gives me -8. So this is the only one that was arithmetic, and my common difference was a -8. Number 5 was the only one that ended up being arithmetic because it was the only one that the subtractions actually worked. Now, I started every single one checking the subtractions because that's easier sometimes than dividing. If you can kind of put that it is not a multiplication or division problem, then you can go straight to checking division. Just make sure you check both so that you know when it's neither, because neither one of them works, or if it's geometric or arithmetic. I did was determine if it was arithmetic, geometric, neither, and then identify the common ratio or difference. And so that's what all of these boxes were telling us. You'll notice that my instructions also say once I figure out what I've got, I need to write the next 3 terms. So that is what I have not done yet. Write the next 3 terms. And so to write the next 3 terms, all I'm going to do is take whatever my rule is. Here it is to multiply by 2. And I'm going to take 48 and I'm going to multiply it by 2. And I'm going to get 96. And then I'm going to multiply by 2 again. And I'm going to get 192. And I'm going to multiply by 2 again. And I'm going to get 384. And there's my next 3 terms. Here I've got geometric. And so I'm going to take 50. And I'm going to multiply it by our 2.5. Because that's my ratio. So I'm going to take 50 times 2.5. I'm going to get 125. Then times 2.5, I'm going to get 312.5. And then multiply it again, and I'm going to get 781.25. So there's my next 3 terms. This one has neither. Can't write. Ratio is 1/3. You can think about this as multiplying by 1/3, or you can think of this as dividing by 3. So if, whichever is easiest for you, I like to think of it as dividing by 3 because then I get 10. Then I get 10/3, which is a decimal, 3.333 repeating. And then my third term, therefore I divide by another 3, is to do 10/9. Which is another natural decimal, 1.11 and repeating. You can leave them in fraction form. That's the easiest way to do that instead of worrying about rounding and things like that. This last one is an arithmetic, so I'm going to actually just subtract -8 every single time. So -4 minus 8 is -12. Then minus 8 again is -20. And then minus 8 again is -28. So those are my next 3 terms. As we saw with arithmetic sequences, there's also a formula for geometric sequence to determine the nth term. So when you want to figure out the nth term just means any term. So any term that you might be looking for, this is how we're going to find it. We're going to use the following rule. This formula is on a formula sheet, so you will not have to worry about it. Any term, a sub n, can be written in a geometric sequence as the first terms times your ratio to the n minus 1. So just keep in mind that a sub 1 is the first term of your sequence. R is the ratio, common ratio, and then of course n is the term you're looking for. Is it the 7th term, the 55th term, etc.? That is the term you're looking for. So you write a rule for the sequence and then determine the sixth term of that sequence. So the first thing that I need to do is determine what my first term is. That's easy. They've given it to me. My first term is 1. The next thing I need to determine is my common ratio. How do I get from 1 to 5? From 5 to 25? From 25 to 125? I can do this by dividing and seeing that both and all of the ways that I'm going to get from one to the other is the number 5. So my common ratio is 5. All I have to do then is plug that into my rule. That is for finding the sum. That is 9. Any term, a sub n, is going to be my first term, which is 1. My ratio, which is 5 to the n minus 1 power. And so sometimes you'll see parentheses put around your ratio just like that. Now I want to find the sixth term. So what I'm going to do is I'm going to say, okay, a sub 6 is going to be 1 times 5 to the 6 minus 1 because my n is 6. And so I'm going to type into my calculator 1 times 5 to the, okay, 6 minus 1 is 5, so 5th power, and that gives me 3,125. That is my sixth term. Looking at this next one, same thing, I'm looking for the first term in common ratio to plug into my rule. My first term is a 130, so 130, and then I want to know my common ratio. How do I get from 130 to 65? To 32.5 to 16.25. And so I'm going to divide 65 by 130. And I'm going to take the next one just to make sure it really is the same thing. And we're going to figure out, all right, 65 divided by 130 is 0.5. Or if you want to think about that as 1/2, you can do that. 32.5 divided by 65 is also 0.5 or 1/2. So my common ratio 1/2, or if you wanted to think about that as dividing by 2, you could do that as well. When I go to put that into my rule, my first term is 130 times my common ratio, which is 1/2 to the n minus 1 power. Especially when we're fractions, you're going to see those parentheses come out around the common ratio. Now to find the sixth term of this sequence, I'm going to plug in the number 6 into that exponent, so 6 minus 1. So I'm going to go to my calculator, and I'm going to type in 130 times 1/2 to the 5th power, because 6 minus 1 is 5. And I got 4.0625. This does not tell me what to round to, so I'm just going to leave that as is. Decimals are acceptable because decimals are also in my sequence. I don't need to worry about changing that into a fraction. That is good enough. Number 8. Number 8, again, same thing. We're going to find our first term, which is 2. And then we're going to figure out our common ratio. How do we get from 2 to negative 8 to 32 to negative 128? So we're going to do second term divided by first term, and we're going to make sure that that is the same thing as third term divided by the second term. So negative 8 divided by 2 is a negative 4, and so is 32 divided by a negative 8. Notice that your ratio this time is a negative number. That's possible when you have alternating positive, negative, positive, negative. So you are allowed to have a negative ratio. Nothing is really going to change when we plug it into our rule here. We're still going to use our first term, which is 2, times our ratio, which was negative 4. The parentheses becoming really important when you've got a negative number, to the n minus 1. So here's my rule. And when I try and find the sixth term, I'm going to plug in the number 6. So I've got 2 times negative 4 to the 6 minus 1 power. So when I plug that into my calculator, 2 times negative 4 to the 5th power, 6 minus 1 being 5, and we get negative 2,048. Last but not least, let's look at number 9. Again, we're writing the rule and determining the 6th term. First term being 135. My common ratio going to be determined as I take 90 and divide it by 135, and that should be the same thing as 60 divided by 90. Now, when I plug this into my calculator, you're going to get a decimal point 6666666 repeating, and if we turn that into a fraction, that is 2/3. So your ratio here is 2/3. That means that your rule for this geometric sequence is 135 times 1 power. It also means that when we go to find our 6th term, we're going to do 135 times 2/3 to the 6 minus 1, or 5th power. And in our calculator, when we go to find that, we're going to get 17.77. If we wanted to turn that into a fraction, again, it does not say what to do. You're going to find that a lot of sequences prefer fractions. So we're going to get way comfortable with having fractions in our sequences. The last couple examples are just some different types of examples that you'll see using the geometric sequence formula. You'll notice that it says we need to find the indicated value, so each of them are going to be a little different. In this first one, we're given the first term in our ratio, but we need to figure out what the 8th term is going to be. You could do 7 times 4 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 until you get to the 8th term, or we can use our formula. We know our first term is 7. We know that our ratio is 4. And we know that we're looking, our power is going to be 8 minus 1. Calculator. We can do 7 times 8 to the 7th power. 8 minus 1 is 7. 7. 4 to the 7th power. Big number, but that's all right. Our 8th term is 114,688. Big number, but that's all right. We don't know our first term, but we do have the 5th term and we do have our ratio. So we can plug that in. If we have the 5th term, we don't have our first term, we can use the letter x. We'll get to that in a second. But we do have our common ratio, which is a negative 0.5. And because this is the 5th term, we know our power is 5 minus 1. So if we kind of take this in stride, we know that this, a 5th term, is negative 68. We do not know what a sub 1 is. We don't know our first term, it's x. But we do have a way to calculate this power here. We've got negative 0.5 to the 4th power. And so we can do some algebra here. We can actually divide each side by negative 0.5 to the 4th power. So these cancel out and then we're left with our x. And in our calculator, we're going to do the following. We're going to do negative 68. Negative 68 divided by negative 0.5 to the 4th power. And it's going to give us negative 1,088. There is our first term. Remember, that is what we were looking for. So we could leave it x, but knowing x is our first term, that's going to help us out there. Number 12, last one. This time around, we're given the first term. We don't know what r is. So we've got the first one. We've got the fourth one. We don't know r, and we're not even looking for r. We're looking for a sub 3. So what are we going to do? We're going to fill in what we know. We have a sub 4. We know that that's 13 times whatever our base is, r, to the 4 minus 1, because this is the fourth term. So the fourth term being 4,459, and that equaling 13 times r to the third power, because 4 minus 1 is 3. I'm going to divide each side by 13, because that's going to cancel this here, and we're left with r cubed. Dividing 4,459 divided by 13, we get 434. Now to undo the cube, we have to take the cube root. So we're going to cube root both sides. And we would get 7. So your r, your ratio, is 7. Now, I'm not looking for my ratio. In fact, I'm looking for the third term. So what I'm going to do is I'm going to go back into my formula, and I'm going to say, look, if I'm looking for the third term here, I'm going to take the first term, and I'm going to multiply my ratio, which is 7 to the 3 minus 1. So I can type that into my calculator here. We're going to do 13 times 7 to the second power. And we're going to get 600, 307. 600, 307. So a sub 3